Before we leave these definitions behind, I wanted to add in something that is implied but not explicitly stated in the notes, so hopefully you're not running out of space, or you can throw in another sheet of paper in there somewhere. But we have some special names for polynomials that have degree something other than 1. So this is a special note. So if it's degree 1, we call that linear, and we've been dealing with that since chapter 1. So if x is the highest power out there is to the 1 power. So like this is negative 3x plus 2, which everybody knows is mx plus b forms. So that's linear. Or 48x, that's linear. Or even if they're both variables in there, that's fine as long as they're only raised to the 1 power, which they are in this case. So that is linear. All right, now degree 2 is called quadratic, and it's going to become very important to you because that's what we're dealing with chapter 6, 7, is quadratics. So if your highest degree is degree 2, so like negative 3x squared plus 2, or 48x squared, or 7x squared plus, or excuse me, 7x minus 14x squared plus 22, but the highest degree is 2, so that means it's quadratic. Or this one, 81x squared minus 49y squared, that's quadratic. It's got 2 variables in it, but it's quadratic. All right, then we could have degree 3. Degree 3 would be the highest degree is a 3. So like this one would be degree 3 because it's the highest degree out there is a cubed. I suppose I didn't have to quite do it that way. Here, I'll make it cubed here, just for the fun of it, so you can see. See? That way it's very similar to the other ones. And then you could have 48x cubed. Or you could have 7x cubed minus 14x squared plus 22. The highest degree is 3. Or you could have 2 variables in it, x cubed and y cubed. But that's okay as long as they're the highest degree is cubed. I honestly don't have to have this cubed. It could be squared. It still would be a cubic. Right? It has to be cubic. Highest degree 3. All right. Now I've realized I've typed so much into this that I've kind of bumped down the next page. So hopefully you can fit all this information in somewhere, or you might need another sheet of paper to put it in. All right, so I will now do this example. Let's see here. So I've already started it. I lost one of my videos. I hate it when that happens. All right, so let's look this over here. I threw in these 2 examples over here, D and E, so you might want to add those in, but I put them in there so you have a little bit more examples. And I wanted to start off with the degree thing. So we start off with degree 1 over here is this one that I added in. That one's degree 1. That makes it linear because the highest power out there is 1, right there with the x. That's your highest power. This one I threw in is quadratic because the highest power out there is a 2, so it's degree 2. This one over here, which was originally A, that part A, B, and C didn't change. I just added in D and E. That's cubic because it's degree 3. The highest power in this problem is a 3. All right, that leads me to these 2. Well, this one's degree, well, we like it when they're all the same variable because that makes it really easy to spot. It's degree 5 right there. Okay. So this is degree 5. There's no special word for that. At least not that I'm going to tell you. And then over here, this is much harder to see because you have 2 variables. 2 variables is always a bit trickier. So we've got 5 on this term, 4 plus 1. We've got 8 on this term. We've got 3 on this term. So it's degree 8 actually. All right. Now we know how to do all that. A couple of this was review, and then we got some special names for a few of them. All right, now we answered the linear, quadratic, cubic thing. That's really the degree. So this is kind of out of order. Degree, that's what all of those are. Okay. Then we want to answer if it's a polynomial, binomial, trinomial, etc. So let's do that. So this one's a trinomial because it has 3 terms. This one's also a trinomial because it has 3 terms. Let's see. The one in the middle is a trinomial. Wow, lots of these are trinomials. Sorry about that. Okay, and these 2 are both binomials because they both have 2 terms. Sorry, there's not a lot of variety in that one. So they're all binomial or trinomial on this one. I didn't make enough difference. So if there's anything with more than 2 or 3, then you would call it just a polynomial. And remember, if it only has 1, that's a monomial. Sorry, that was kind of boring. All right, now do we answer, oh, the last bit. Do they have 1 variable or 2 variables? Okay, so that's kind of easy to spot. Let me throw it in here. So this first one has only 1 variable, right? 1 variable, x, that's it. The next one also has 1 variable, x. The next one has 2 variables, x, or p and q, sorry. The next one has 1 variable, just x. And the last one has 2 variables, x and y on that one. All right, we're done with that. Now let's do some combining of like terms. So when they're like terms, remember like terms means they have everything the same except for their coefficients. Then all you do is add the coefficients of the terms. So let's look here. We've got 4a cubed b, hold on, let me type it up. There it is. Okay, so you want to look for where they're like terms. You want to have the same letters to the same powers. So 4a cubed b, and I'm going to kind of underline it a little bit so you can see it. I'm going to do double underline. That one is a like term. Well, this one's no good because that's got b squared. This one's no good. But it's a like term with this last one, a cubed b. See right there? Those ones are like terms. Okay, so if you have 4 of them, 4 of something, take away 1 of them, that leaves you 3a cubed b. Now these two in the middle are both a squared and b squared. So if you have negative 7, take away 2 more, that's minus 9a squared b squared, right? You combine like terms. You put these two together. You add or subtract their coefficients, and you're done. I'm going to box this because that's our final answer. And you can't combine what's left because what's left is not like terms anymore. So you're finished right where we stopped. All right, now what about adding 2 polynomials? Now, please, please, please keep track of what you're doing here. So if you look at this, do you see how you've got the parentheses, and a lot of students start multiplying without thinking. But if you look, there's an operation in between those 2 parentheses. It's adding. So you're going to add these 2 polynomials. So the parentheses in this case do not mean multiplying. They just mean they're grouping together the items. So let me type this up. There we go. All right, so this is the problem. So what I'm going to do is I'm going to sort of distribute that addition and get rid of all my parentheses. So I'm going to 3p squared. And I'm going to look for what else is a like term. Well, actually, I'm going to write it this way. Minus 5pq plus 7q squared plus negative 8p squared. So I'm going to minus 8p squared plus 5pq minus 2q squared. Oops. There we go. All right, now I'm going to look for some like terms here. I've got the 3p squared, and let me see what I can do. Got that one and negative 8p squared. Those ones are like terms. All right, so I'm going to put them together. So if you have 3, take away 8, that gives you negative 5p squared. All right, now I have a minus 5pq plus 5pq. See that? They're like terms, and they're going to go away because if you have minus 5 of something and then you add 5 of something, you end up with 0 of something. So that's gone. There's no pq anymore. And that leaves me with a 7q squared minus 2q squared, so that means plus 5q squared. And this is an instance where I'm actually going to rearrange the order just because I like the positive one being in front if I can help it. And they're both degree 2, so it actually doesn't matter. They're both, it's descending. It's not descending, it's not ascending, it's not doing anything because they're both second degree. So there we go. So the parentheses on that one is really kind of to fool you. Actually, the reason they put the parentheses in there is because of this negative 8 right here. They're trying to make sure that you keep it separated. Okay, that's all. So it's just a grouping symbol kind of a thing, but there's nothing to do inside of that parentheses. Now that's not the case for the next example where there is a significant difference and we got to pay attention. So let me type it up. One sec. Okay, Now here, the parentheses is not just for aesthetics. It's here for a very specific reason. It's saying to you, look, you want to take this whole thing over here on the left and subtract away this entire equation on the right. Okay, so the front parentheses still don't really matter that much. It's 6x squared minus x plus 5, no problem. But the back parentheses, I want to subtract all of them. So you have to distribute your negative. It's minus 2x squared plus 7x, right? Because it's minus a positive 2, minus a minus 7. Minus a minus 7 is plus 7. Minus a positive 3, so that makes minus 3. You have to distribute, better make a note, distribute the negative. Right? That's why the parentheses matter so much for subtraction problems. For addition problems, you could take it or leave it. But for subtraction, it really matters because you have to subtract away all of this. All right, now we'll see some like terms. So we got the 6x squared here and the minus 2x squared here. They're like terms. So 6 take away 2 is 4x squared. And then let's see, we got a minus x right here and a plus 7x. So let me give that like a little arrow or something. So minus x plus 7x, right there, those two go together, and that makes a plus 6x. And then you got your numbers. 5 take away 3 means plus 2. And there you go. And it's actually already in descending order because I'm that crafty. Okay, now we have to have a couple more definitions real quick. We have a polynomial function. So remember functions in chapter 1, we learned about them. They mean that every x can only go to one y and all that good stuff. Okay, so that's still the case, right? That's what a function is. A polynomial one is just the one that's equal to a polynomial. So I made up one here. F of x equals this big ugly mess, right? That's in terms of variable x because the only variable in here is x. So it's a function of x because that's the variable you've got. Functions that have more than one variable we won't deal with that much in this course, but you would deal with them in pre-calc. All right, then a quadratic one is a special polynomial function. It's a polynomial function that's of degree 2. And if it looks like ax squared plus bx plus c, in this case b is negative, that's fine, that's called being in standard form, where the x squared goes in front and then the number, or then the x and then the number. All right, so I have a polynomial function here. It's a very special one. It's a quadratic one, right? See how it's squared? And they want us to find f of negative 2. Okay, so I rewrote it. Here's f of x. I'm going to find f of negative 2. So I'm going to write negative 3, but instead of writing x, I write negative 2 squared minus 2 times negative 2 plus 6. Okay, so that's equal to, there we go. Negative 3 times, okay, now negative 2 times negative 2 is positive 4. Poof, and if you don't believe me, parentheses, negative 2, it's got to be in parentheses because the whole thing is squared, right? Not just the 2 part, but the negative part. And if you square it, you're going to get positive 4 because negative 2 times negative 2 is positive 4. And then it's right here, plus 4, because negative 2 times negative 2 is positive 4 plus 6. So this is negative 12 plus 4 plus 6, which is negative 2, right? Because it's negative 12 plus 10, excuse me. And there we go. All right, so we practiced a little bit of substitution. That's stuff we've already seen way back actually in section 1.6. You first learned how to substitute, and we're just throwing it back at you. But with quadratics, you got to be more careful, especially with the negatives. Matter of fact, I'll make a note. Note. There we go. Be careful when substituting negatives into a quadratic, right? Because they turn positive a lot of the time. So you got to be very cautious, right? Use parentheses when you do it. Use parentheses to keep it all straight. All right, we don't have time to do the graph, so that's where we're going to start next time with graphing x squared by hand, i.e. we're going to use our calculator to help us. All right, I'll see you then.